Morning. Today on our show we will be discussing biodiesel.
Biodiesel is a type of fuel that is being used as an alternative source to fossil fuels in many parts of the world.
Right, and biodiesel is an organic molecule called an ester. It is made from oils that are triglycerides.
That word triglyceride may sound familiar from 9th grade biology. If you don't remember, triglyceride consists of 3 fatty acid hydrocarbon tails linked to a molecule of glycerol. To convert the triglyceride into biodiesel, the process of transesterification is used to get rid of the fatty acids by adding alcohol and a base.
It sounds complicated, but the fact is lots of people make their own biodiesel. Many people make their own biodiesel from waste vegetable oil because waste vegetable oil is a triglyceride.
2 of our reporters are in New York retrieving waste vegetable oil from a local restaurant right now. Let's tune in with our reporters and see what they're up to.
Hi, Sophie and Julia. We're here reporting from New York City from the Upper West Side, and we're about to go to Cafe Blossom to obtain a bottle of WVO, waste vegetable oil, from a local restaurant. We're going inside but in a second, but first we want to just let our viewers know why we're even doing this. Some of you out there might be wondering why you convert vegetable oil into biodiesel. The reason we're converting a triglyceride into an ester is to create a simpler form of the liquid. We want to simplify the ester group that's attached to the glycerol in the triglycerol. Now let's see what Maddie has to say outside of Blossom.
Hi, we're here at Cafe Blossom. We're gonna get some waste vegetable oil to turn into biodiesel, as Anthea was saying. And we're also converting the vegetable oil into biodiesel because biodiesel is a mixture of esters. And this means that we can create different kinds of fuel from different kinds of vegetable oil. And we plan on using waste vegetable oil in order to produce biofuel because it's sustainable, and we can easily separate the fatty acids from the glycerol in the molecule, thus giving us the materials to form transesterification. We're going to go inside Cafe Blossom to get some vegetable oil. Come on, guys.
Ooh, that's cool.
Yeah. Let's look at the fryer where the oil really comes.
There we go. It's right there.
So now we're
in the kitchen.
We're in the kitchen. Getting our waste vegetable oil. Alright. Thank you so much.
You're welcome.
That's all we ordered?
That's perfect. Yeah.
Great.
Thank you. Oh my god.
That's fine. Don't worry.
Don't worry. Yeah.
Thank you so much.
Thank you guys.
Bye.
We got it. Yeah.
Looks like those 2 are turning a cold New York day into a fun, educational, sustainable day.
Yes, waste vegetable oil is one of the most sustainable sources of biodiesel because the waste vegetable oil would otherwise be discarded, but instead it can be recycled by being converted into biodiesel and then used to fuel vehicles. The waste vegetable oil comes from industrial deep fryers in potato processing plants, snack food factories, and fast food restaurants. In the United States, there has been an excess amount of 11 billion liters, which is 2.9 billion gallons, of waste vegetable oil annually.
Here's an interesting fact. If all of the excess amount of vegetable oil were to be collected and used to replace the energetically equivalent amount of petroleum, around 1% of the United States of oil consumption could be replaced. Therefore, waste vegetable oil as a source of biodiesel is sustainable because it recycles the vegetable oil used in restaurants and makes small steps towards replacing the vast amounts of oil the United States uses. You know, with all the palm trees here, we could use palm oil as a source of biodiesel because it is also a triglyceride.
Sophie, please. You know that's not sustainable. It leads to deforestation. We need a whole other episode to discuss that.
Well, that's all the time for today's episode. Thanks for watching our feature on waste vegetable oil as a sustainable source of biodiesel.
We are titrating the waste vegetable oil in order to determine its concentration of free fatty acids. Fatty acids are present in the waste vegetable oil since the oil was previously heated with water when it was used for cooking. This process is called hydrolysis and yields free fatty acids and glycerol.
The amount of free fatty acids inside the waste vegetable oil will determine how much base catalyst we will need to use for our transesterification reaction. A transesterification reaction is a reaction in which pure lipid is combined with an alcohol and a catalyst in order to form esters and a glycerol molecule.
Once we use titration to find the exact concentration of the free fatty acids inside our waste vegetable oil, we can calculate how much base catalyst we need to use for our transesterification reaction.
First, attach a 10 milliliter burette to the ring stand. Make sure that the burette is clean and dry. There should be no leftover liquid inside of it.
Measure in a graduated cylinder and then pour 5 to 7 milliliters of 0.1 molar NaOH into the burette.
Next, measure in a graduated cylinder 10 milliliters of isopropanol, the solvent, and transfer liquid into a 25 milliliter Erlenmeyer flask.
Measure 10 milliliters of waste vegetable oil in a pipette and then combine inside the Erlenmeyer flask with isopropanol.
Swirl this together and then add 2 to 3 drops of phenolphthalein, an indicator.
Now place the Erlenmeyer flask under the burette and slowly open the stopcock so that NaOH drops into the flask.
Continue to add NaOH dropwise while swirling the flask until the liquid turns pinkish.
Once pink, close the stopcock and watch if color persists for 15 seconds.
If yes, record the volume of the NaOH left in the burette to 2 decimal places.
Now that we have finished our titrations and have calculated the appropriate volume of KOH that is needed in the transesterification reaction, we can continue on the path to making biodiesel.
In the transesterification reaction, triglyceride molecules can be converted into a simpler form, meaning that one ester group is converted into another. Waste vegetable oil will react with ethanol, an alcohol, and potassium hydroxide, which is a catalyst, to create biodiesel and glycerol, which is a byproduct of the reaction.
The role of the catalyst, the potassium hydroxide, is to neutralize the fatty acids as well as work as a catalyst to induce the reaction with ethanol.
Now that we understand why we are making biodiesel and what's going to happen, let's get started. First, we have to obtain a 25 milliliter flask and measure its mass on a scale.
Using a burette, we must extract 10 milliliters of waste vegetable oil and add it to the flask.
We need to record the exact mass of the waste vegetable oil once we add it to the flask.
Now we will put a magnetic stir bar in the flask.
Using a pipette, we have to add 2 milliliters of ethanol to the flask.
We have to now add the appropriate volume of 10 molar potassium hydroxide to the flask according to what we calculated from our titrations in part 1.
Now we have to heat the mixture at 50 degrees Celsius for 30 minutes, so we have to put the flask on the hot plate and turn the heat and stir levels onto low settings.
We need to monitor the temperature with a thermometer every few minutes.
We want the temperature to stay around 50 to 55 degrees Celsius, so when it gets above 55, we have to take the flask off the hot plate and put it on low setting on a magnetic stirring plate.
When the temperature gets close to 40 degrees, we can put it back on the hot plate.
We have to take the flask off of the hot plate after 30 minutes and turn off the hot plate.
The next 2 steps we will do will be an acid wash and then a water wash. The purpose of these steps is to purify the biodiesel by eliminating any contaminants including ethanol, water, potassium hydroxide, and glycerol. It is important to eliminate these substances from the biodiesel because not having pure biodiesel could negatively affect engine performance. If biodiesel is mixed with water, it could be very dangerous when the biodiesel is used in a diesel engine because water and biodiesel could form an emulsion. Also, Remnants of ethanol in the biodiesel could cause a fire hazard in a diesel engine. Therefore, it is important to wash the biodiesel with acid and water, centrifuge the mixture, and then discard the contaminant later. Now that we understand the importance of purifying the biodiesel, let's start our acid and water wash.
We need to transfer the reaction mixture into a centrifuge tube and pour an equal amount of water into another centrifuge tube so that the centrifuge is balanced.
Now it will centrifuge for 5 minutes and we should end up with 2 layers.
The purpose of the centrifuge is so that we can separate the biodiesel from the glycerol.
The biodiesel should be the top layer.
Using a pipette, we must discard the lower layer which contains glycerol and KOH catalyst into a waste container.
Now we combine the crude oil, which has not been refined or processed yet, into one centrifuge tube.
Then we add 1 milliliter of 0.1 molar acetic acid to the tube and close the tube.
We then carefully and gently invert the tube 5 times to mix the acetic acid evenly within the tube.
Then we insert the tube back into the centrifuge for 5 minutes.
When we take the tube out again, we discard the bottom aqueous layer into the labeled waste container.
We then repeat the extraction step, but instead we add 1 milliliter of distilled water into the tube. Now that we have the washed biodiesel, we use a pipette to transfer it to a pre-weighed 25 milliliter flask.
We then will heat the sample to about 70 to 80 degrees Celsius for 10 to 15 minutes to evaporate any residual water left in the mixture.
Finally, we will obtain the mass of our dry biodiesel.